Hi ladies and gentlemen, I did a failure analysis on my non-starting Toyota Sienna. I took the Sienna starter out of the Sienna and I brought it into my bedroom here. This is where I sleep, on a piece of cardboard. And I've torn it the heck apart. But before I did, I've drawn a circuit because I like to draw circuits. This isn't very physically the same, but electrically it's kind of right. You got a battery. You got the body of the car like the engine that historically has been used to pass the negative flow of electricity back to the negative side of the battery. And there I show you the motor goes to ground of the engine. And there's an M for motor, and M for motor goes to connect to your solenoid. Solenoid is a chunk of metal, plate of metal that slaps against these two posts to create a high amperage path for your 12 volts. Now the way batteries work, electrons spew out of the negative side, travel inside the metal, travel through this new path and back up. Now the solenoid's a funny creature. It has a connection here and also a connection to ground. The resistance from here to the motor winding side is about 1/3 of an ohm. 1/3 of an ohm at 12 volts. Well, let's say 1/4 of an ohm. My meter's not the most perfect meter. It's going to give us 25 to 30 amps, which is what the fuse is rated for on that ignition switch relay. And in fact, there's a relay. This is a simplified drawing. So actually, the ignition switch operates a relay, which makes a connection, so on and so forth. Just to point out, once the high power needed to initially throw that plate of metal there and pull this this thing hooks on to something in there and it gets pulled out, which then yanks that forward to engage the engine. Once that's done, then the solenoid simply needs to hold it there. It doesn't need to actually move it there, it just needs to hold it there. So they've done an ingenious trick to save all the current they can for the motor current flow. They have either a second coil, or they do something with a resistor or something that goes directly to ground. And that has a resistance to allow maybe 10 amps or 8 amps. So the holding current is maybe 8 amps. The driving current to get things moving is more like 25 amps. So that's the job of your solenoid, which is right here. The problem with this solenoid turned out to be corrosion on the connections from one chunk of metal to the next. So out of an abundance of caution, I scraped this nice and clean. It used to be pretty cloudy with corrosion. The solenoid, this starter motor is kind of below the battery, and I had a battery failure, so it's sprinkled some sulfuric acid over various things, so on and so forth. Now here's our motor. The main action of the motor, you got your high amperage entry. That's the one that's right here, connects to right there. So the battery is providing your high amperage to that place. It goes to the various, I'm pretty sure it goes to the various brushes. I got 4 brushes there, nice little brush there, and 3 and 4, making contact with these little copper teeth. Nice and smooth movement there. And I measured the resistance from the wire that goes to the brush and then up to the top. Pretty much gets 0 ohms. So nice connection. The brushes are not worn out yet. There's the top of the motor. You can see those nice thick wires. Well, the end result is after they've flown through the motor coils, they get splashed out to this chunk of metal. 1, 2, 3 Phillips head screws hold that little metal plate, and you may be able to see the 2 copper wires attached to it, which is then screwed securely there and there. So now that's trying to connect to the negative side of the battery by connecting that negative side to this chunk of metal. Well, it has to travel through the iron body, nice thin piece of iron. And if this surface got corroded, which it has in my opinion, which then binds to that shiny, semi-shiny surface, which is kind of corroded in many spots. If that corrosion builds up enough, that's where it can shut your starter down. So to cure the problem, we need to clean, to make it shiny, that surface, this surface, the other side surface, which finally mates with here, so we can have a nice, friendly, low ohm connection to ground. So I'm going to do that scraping and digging, and I'll put it back in the car to see if my theory is anywhere close to being reality. So thank you for watching part 1 of failure analysis of a Toyota Senna. But of course I found out these are used in many Toyotas, this particular starter. Alright, thanks for watching.